Hello, everyone. My name is Alex Glikson. I'm from IBM Research in Israel. And I'm going to talk about the recent trend called serverless, and also how is it related to FIWARE or should be related to FIWARE going forward. Let's just do a quick check. So who is familiar with the term serverless or have heard about Amazon Lambda service? A few, but not too many. Okay. So hopefully you will learn something during this session. So I'll go briefly through some definition what serverless means. And then I'll talk a bit about a project, open source project called OpenWhisk, which provides serverless capabilities. And then I'll talk a bit about challenges that there are in this space. And at the end, hopefully, we can get to a discussion on how FIWARE fits, or how serverless fits into FIWARE in general. So this is my definition of what serverless means to me, because I think it means different things to different people. So in my view, serverless is a sort of a next generation of a platform as a service when developers essentially can focus on writing the business logic, and someone else takes care of the infrastructure. That's where the name came from, essentially. More specifically, it is focusing on development of services which are event-driven or can be decomposed into a set of events or requests and handlers of those events or requests. So a decoupled architecture based on some basic principles that I will elaborate on in a moment. And I think one of the main reasons that this technology is interesting is because this enables very nice properties around scaling, metering, and chargeback of the capabilities that the service provides at a granularity of individual handler invocation. So as opposed to the regular infrastructure cloud model when you pay, for example, for a VM for an hour, here you pay for a single invocation request of 1 second. So this is very attractive for many use cases, and as we'll see later on. And now this is entirely my interpretation of why this term serverless kind of emerged in terms of the name itself. So as far as I know, it essentially evolved from the Amazon offering in this space, and for Amazon it was basically the first service that was fully managed in terms of the underlying infrastructure. So in that sense, serverless meant that you don't need to manage the underlying VMs. And now the term sticked, so it also describes other similar capabilities by various vendors. So hopefully it is not too confusing for people, because when I've heard serverless for the first time, I thought that, well, it's a bit difficult to run applications without servers. So here the idea is basically that the developer doesn't need to care about servers, which is on its own is not new, but that's still that's the name. So let's look at a simple example. Some of the experiments that we did with OpenWhisk in this space. And it is essentially addressing some simple IoT-based scenario where you can have, let's say, a refrigerator, a smart refrigerator with some FIWARE technologies in it, perhaps. that can report to some IoT service in the cloud of some problem or issue. For example, some spare part needs to be replaced. And this IoT service usually can generate events or can trigger some actions based on the information that it receives from the field. So here we have a simplified architecture of basically triggers and actions. So those blue things are triggers, and those oval things are actions, and those are persistent parts of the application. So we can see here an example of an application that takes care of this incoming event indicating something happening with the spare part of a refrigerator. And at the end of this workflow, the end result here is that an email is sent to the owner of this refrigerator, for example, saying that the spare part is on its way and will be delivered soon, if, for example, there are all the proper arrangements. So let's look at it a bit closer. So there is an initial event, and then we are decomposing the actual function into 3 parts here. One is analyzing the event, identifying the source, what exactly happened, and the results. So all those actions are stateless in nature. So at the end, they update some stateful service in the cloud. In this case, we are using Cloudant. So in this case, the result of this analysis is written to a database called service. It's not very well seen here. Now, these days, many databases are able to generate change events. So in this case, every time a new record is written to the database, an event is triggered, and we are configuring this event to be the trigger of this action that is responsible for creating the order for a new spare part. And the output of this is updating the database of orders. And similarly, there is another step here that when a new order is entered into the database, it triggers another, sometimes it's called a nano service, which actually alerts the customer. So it could be, well, in this case, it is triggered based both on order events and periodically. So it's not that on every event this thing happens. So it's kind of more of a batch processing of pending alerts that trigger some external service. In this case, it's SendGrid to send email to the customer. So I think this is a rather typical use case for what is called the serverless paradigm, that we are essentially decomposing the logic into very small, very short-running pieces of logic that are interconnected between them through some persistent services and some event triggers or some external requests. We'll see in a moment that another way to trigger such a sequence could be through a REST API call, for example. So I've tried to put a bit more organized definition of serverless. So essentially, it is cloud-native design pattern, which comes with a programming model and the runtime architecture that's aimed at simplified, faster, and more efficient development and operation of certain applications of the sort that I've described. And just to recap on the pattern, so there is a set of business logic functions and a set of triggers, which could be events or requests. And well, here we are going into some implementation details already. So given that the business logic is code provided by the developer naturally, then we have to run it in some sort of sandbox. Yeah.
Just the definition of it, that seems like a sensible definition, but it's still very new. So
it's my definition, so that's the disclaimer. It's not an official definition. I made it up yesterday. So I think there is something in Wikipedia about serverless which might be somewhat different than this one. So here, yeah, so you need the sandbox, or the provider needs to run it in the sandbox to protect it from the rest of the functions provided by other users potentially. And in order to guarantee the elasticity, so there is item number 3 here. So the underlying runtime and architecture is built in a way that it is inherently elastic. So here in the architecture here, essentially it is completely transparent. There could be thousands of different functions running at the same time if there are many events coming at the same time. So there is nothing that the developer or the operator of the application needs to do to handle scalability here. So in order to guarantee this sort of scalability and elasticity, we need to make sure that, or the provider needs to make sure that each function is short-lived and ephemeral. So those are the limitations or restrictions of or typical limitations or restrictions of serverless platforms. But on the other hand, it allows much better elasticity, scaling, chargeback at very fine-grained granularity. And it's, for example, it could be at 100 millisecond granularity. So, so if you have, for example, if you have a few million requests per month, then, well, there are some studies that show that it could cost you like $1 or something like that, all the processing, as opposed to having a long-running VM, which would typically cost you several tens of dollars for each such workflow. So a few words about what is happening in this space in the market. So Amazon is the pioneer of this space. So they launched Amazon Lambda about 2 years ago, and they had a large conference recently in Las Vegas where serverless was a very popular topic. So there are lots of companies that are experimenting with serverless on Amazon and not only on Amazon, also Google and Microsoft are, they also have similar or conceptually similar offerings in the market, and so is IBM. And there are also some many smaller players, I'm just listing here some few, which are targeting smaller niches of applications. For example, PubNub, I think it's focusing on sort of stream processing applications at the edge. So it's an emerging market in relatively early stages. And one technology here that I would like to highlight is OpenWhisk, which is an open source. It has been recently accepted for incubation in Apache, under Apache Foundation. And it was originally developed by IBM, but there are some additional contributions now from the community. And we have a commercial offering based on exactly the same code base as part of our Bluemix offering. So in Bluemix now, in addition to VMs and containers and Cloud Foundry runtimes, the developer can use OpenWhisk platform as part of the hosting options. Of course, due to its unique characteristics, serverless is not good for everything. So it's quite good for, so there are some few examples of use cases where serverless could be a good fit, like microservices, mobile backend, and so on. IoT, I think especially in the context of FIWARE, IoT is a promising use case. Some workloads which might not be a good fit, for example, if you want to develop a new database, then that would not be necessarily a good fit, or some very computational intensive or network intensive applications that you would essentially need lots of resources for potentially large durations, or with applications which are extremely latency sensitive. So those are, at least at the moment, are less relevant for this serverless world. So a few examples. So those are from this recent Amazon conference. So for example, there's there's an example from a company dealing with some analytics of media. So they have this entire pipeline built. So for those of you who are familiar with Amazon services, they have this streaming middleware. There is this middleware, the service that persists data in object store. So they use Amazon Lambda to read data from a stream and write it in batches into object store. So this is the icon of the Amazon Lambda. So you see it here, here, and here. So first one is to move data from the streaming middleware into master data set, which is object store. Then there is another little pipeline taking data out of the master data set into some intermediate storage with some processing here, in this case splitting between data of different tenants. And then there is another ETL style of logic from here to here. And all of this is running with 0 VMs. And essentially, all the computation that is being done here is entirely triggered by the flow of the data between those services. So I think it's a quite powerful example of what's called serverless architecture. Another example here is from a company called Bustle. They also have a streaming middleware here, and they have Lambda functions that are processing incoming requests from here. So there's an API gateway here at the top that is not shown here. So there is an initial processing of the requests, and then there is a set of Lambda functions that basically doing some transformation of those requests to feed different services or persistent stores. So it could be format transformation, it could be augmentation of data, it could be batching, it could be all kind of different things. Here there is another event with, I think, a similar pattern. There is the incoming request. So this is for CI/CD, which is, I think, is very interesting use case. So if you want to build a continuous integration, continuous delivery pipeline, then obviously this entire pipeline is driven by events like commits, code commits. So it's very natural to model this pipeline as a sequence of actions, some persistent stores, some queues, and lots of small functions. So this is, I think, one good example of that. And they're using different persistent backends here. Well, one more. So if I'm trying to, so I was asking myself why this is happening now, because in terms of the individual technologies here, essentially there's nothing new. PaaS existed for many years, and event-driven is not new, and so why now? Why this is happening now? So I tried to answer this question, and it seems that there's a sort of a perfect storm here, combining 4 different independent trends going on in the industry, which together somehow converged into this serverless paradigm. And this is one, again, this is my personal interpretation. So one is the evolution of PaaS. So it becomes more of a mainstream, I guess, that developers are enjoying that they just need to write the business logic and someone else takes care of all the rest. There are more and more event-driven use cases or applications that can be architected in this, following this pattern. For example, IoT or mobile, which are very popular now. In terms of the underlying technologies, the various containerization or sandboxing technologies became much more mature in the last few years. So, for example, OpenWhisk, and I'll talk about it in a moment, is using Docker underneath with some extensions. So it is available out of the box, and it's very convenient to use for isolation of those different runtimes. And there is also what is called sometimes API economy. So there are lots of services available in the internet that provide some sort of API as a service that you often is being charged by API call. So in a sense, I think serverless is an extension of that paradigm into larger cloud-based architectures. So if you are developing a cloud-native application and you have different pieces of your function running potentially in different places or decoupled between them through this event-driven architecture, then this becomes a really good use case for the serverless model. So a few words about OpenWhisk. So this is an open source implementation of a serverless platform. So let's start from the left here. So essentially we have the notion of a feed, which is an event source in a sense. So you can have different kinds of events incoming into the system, generating triggers. And within the OpenWhisk runtime, you can have a number of what we call actions, which could be developed in different programming languages. So there are some languages which are supported built in OpenWhisk, but you can essentially write in whatever language you like, because it also supports kind of black box Docker-based actions. So you can provide your own Docker image on Docker Hub, for example, and the system would pull the image into the runtime and would manage the life cycle of the action the same way it does for other kinds of built-in action languages. And by the way, the underlying implementation for those is also based on Docker, so that's why it's rather straightforward. And of course, actions, as we saw previously, they could write to some persistent stores. They could invoke some external services. And in this case, there is also support for chaining of actions. So if you have a more complicated workflow, you can decouple it into smaller pieces and even develop those individual actions in different languages, maybe based on different libraries that don't necessarily exist in other languages and so on. So so a few nice things about OpenWhisk. So first, it is fully open. So as far as I know, it's the only effort that I'm aware of a serverless platform which is open source and also developed. So there is an intention to grow the community. So if everyone is interested, you are welcome. It's all on GitHub and on Apache. It's fully extensible, so the developer can add their own event source types or feeds here. Of course, actions and packages, which is a kind of a way of putting things together. As I mentioned, it supports pretty much any programming language. There are some basic composition capabilities and the basic promise of per event or per request scaling and metering. So one thing that is in progress now is adding support for what is called an API gateway, which is essentially an additional event source in a sense. So the idea here, well, I'll get to it in a second. So the basic idea is that if you have a REST endpoint, then you could treat individual requests coming to that endpoint as triggers in this serverless architecture. So I'll show a bit more of how this is designed in OpenWhisk. So essentially, it could be events or it could be requests, which have inherently more synchronous nature. So this is a simplified diagram of how OpenWhisk is built internally. So there's this Nginx front end. There's a controller. It has a database, CouchDB in this case, Kafka for messaging between the controller and the endpoints, which have invokers that actually run and manage the endpoints with Docker. And there is a console for coordination. So as you can see, I think one of the nice things about this industry in general is there are lots of open source components available that you can combine together to build quite powerful architectures. So as I mentioned, OpenWhisk is very extensible, so there is this partial set here of what is called packages. So each of them is comprising some feeds and actions for a certain external system, which could be just a timer or some set of utilities is also included. So there is some databases like CouchDB, there is object store, there are some messaging protocols like MQTT, Kafka. There's integration with Node-RED, which is also, I think, very interesting, especially in the IoT context. GitHub, Slack, some IBM Watson services, and also webhooks. So essentially, every external system that can generate webhooks can be easily integrated into something like that. And so there are some examples here of the CLI, which refer to the example I showed in the beginning with the fridge and the events that are in the spare parts. So essentially, I guess the idea here is that there is a REST API that OpenWhisk surfaces, and also a CLI that allows you to create actions by just specifying a file with the action code, or it could be a package if the action is a bit more complex. You can invoke actions manually, passing the parameters. Or, of course, you can create the triggers, which is a more real use. So when you create a trigger, you specify what kind of feed this trigger is coming from, and some parameters that customize the particular feed instance. And then we have a notion of a rule, which is essentially a binding between a trigger and an action. And this is pretty much all needed to create the architecture that I showed in the diagram previously. And also the implementation of each of those actions are just a few lines of JavaScript code. So few things which are more recent. One which is still under development is the API gateway. So Amazon also has an API gateway integrated with Amazon Lambda. So essentially, the idea here is, as I mentioned, instead of reacting to events, we want to react to REST, to HTTP requests coming from external systems or from users. Or in many cases, it would be a mobile app or a browser. So some client-side code invoking some serverless architecture at the backend. So this API gateway is integrated with OpenWhisk actions. And essentially, all you need to do is you are defining the HTTP endpoint, and you are saying which action do you want to map. So each time, so there is a runtime that is part of the platform, and you are essentially defining a new REST endpoint, and you are mapping each request of a certain type to a certain action in OpenWhisk. So it's a very powerful concept, and if you combine this with something like Object Store, then you could build entire complex web applications without having a single virtual machine or container running all the time. So essentially, API gateway is the only thing which is long running here, and it is also provided as a service. I mean, the API gateway, the runtime of the actions, and the storage. So you don't need to have your own custom runtime, which is long running and needs to be managed. How much time do we have? So a few other things which are going on in the OpenWhisk community. So there is an OpenWhisk debugger, which, so as you could imagine, and I'll talk about this in a moment, debugging of such an architecture becomes a non-trivial task because everything is so distributed. So there is a guy who developed a debugger, so you can actually put a breakpoint on a particular action and interact with it essentially from your laptop to figure out what is going on. Another thing which is also, I think, interesting and relevant in the context of FIWARE is the ability to run OpenWhisk stack on OpenStack. So there is a set of, so OpenWhisk itself is deployed with Ansible, so there is a little integration here of how to run it on a set of OpenStack resources. So this is also available. And there are various, I think there are various additional efforts to integrate OpenWhisk with popular open source projects. And FIWARE naturally is also in this category because, as I'll mention in a moment, FIWARE has I think a set of attractive use cases for serverless and also an architecture which can integrate nicely with this paradigm. Some challenges of serverless architectures. So first of all, it's a rather opinionated programming model. So it's not that you can write whatever you want and run it here like you almost can do on a VM or a container. Here you have quite significant restrictions, but in some cases they actually help you to build better applications. And there is quite a nice alignment between what serverless assumes and the well-known 12-factor approach for cloud-native applications. So there is a slide in the backup that shows the mapping between the two. So one challenge which might be important in some cases is the latency and the overhead of the individual action invocations. So this would be especially challenging if you need to handle large throughput of small requests or events. Then you don't have too much to do per request. So there is some ongoing work to make those use cases more efficient with serverless and OpenWhisk in particular. Also in terms of managing state, if your application is, for example, very memory intensive and you have some, let's say that you want to do MapReduce or something like that, so you would typically have, so MapReduce is distributed, but it is very resource intensive and memory intensive and network intensive. So at the moment there are some serverless as it is today is less suitable for this sort of use cases, but there are some ongoing effort to introduce some additional capabilities to make this work better. One area which is rather active these days in the community, in the broader community around serverless, is the life cycle of composite applications. So even if you managed to decompose your application into, let's say, 20 different functions, now you need to manage the life cycle of those 20 different pieces of code somehow in terms of versioning, deployment, dependencies, and so on. So there are some efforts to address this need, even more than one effort. Another area which I briefly mentioned is around monitoring, error handling, testing, debugging, and so on, which becomes challenging due to the high distribution of the applications. And there are also various efforts at different levels of maturity to address this. Now this is the last slide. It is the last mandatory one. I have a few more. So some thoughts of how serverless in general and OpenWhisk in particular could fit the FIWARE architecture. And I guess this slide is primarily targeting developers who might want to contribute to the development of the FIWARE platform. So I think the value proposition here is rather clear. So all the benefits that we saw previously are applicable to FIWARE applications. So it's a very nice model that it could integrate nicely, I think, with the notion of FIWARE GEs, which are essentially individual decoupled services that can be integrated into this sort of event-driven architecture. So for example, a set of actions based on OpenWhisk could invoke different services or APIs of FIWARE generic enablers. Another way to integrate things would be by integration with NGSI and the context broker. So there is a natural fit here to have, for example, a feed provider that will integrate with Cygnus to forward events from the context broker to actions running on OpenWhisk, and vice versa. Actions could trigger or update context data in the context broker. So it seems that there might be a nice fit here. So there are some questions here, for example, regarding the user experience, because at the moment OpenWhisk doesn't have a web UI. So maybe there are some opportunities there to either to integrate it with the FIWARE portal, or maybe with WireCloud or something else, or maybe adopt some of the emerging efforts around which are more UI focused. So that's it. Any questions, comments?
So, you talked about one of the benefits of the serverless model being very fine-grained accounting. But it wasn't clear to me in the OpenWhisk architecture that there is support for all of this. So the question is, A, is there support? And B, if there is, I can imagine that it would have quite a lot of overhead because it's really very fine-grained modeling.
Yes, so OpenWhisk does support fine-grained metering and resource management. Of course, you can do billing on top of that. And actually quite a bit of effort within OpenWhisk development was around building a layer on top of Docker to allow reusing Docker containers. So it became obvious that you cannot launch a new Docker container for each action invocation because it would be too expensive. So there is a layer on top of that that essentially manages this in a much more efficient way. And by the way, I think one of the research challenges could be to build some sort of replacement of Docker or enhancement to Docker that would meet the requirements of something like that. Maybe with some limitations. So Docker is probably too general purpose for something like that. But given all the advancements in the containerization space and the run C and all that, I'm sure that there are opportunities there to run a more efficient runtime, which is on general purpose on one hand, but suitable for this sort of latencies and overheads on the other. Any other questions, comments? Okay, thank you very much.